Hi, Steve here at the SJCOE Fab Lab, and we are super excited about Perseverance landing on the surface of Mars real soon. In fact, it's going to be on February 18th. It's such a big deal that we're throwing a Mars landing party. We have several activities for students to do just to get ready for this big event. We've already done one activity with coding with Scratch, and today we're going to look at how we can make a model of a rover. We're going to model what we make off of Perseverance, but you know, not every rover or robot in space needs to look the same. We are also going to be joined by friends from NASA, and they're going to tell us a little bit more about what's on the rover, what it does, why it looks the way it looks. So let's get started. We're going to use two different technologies to do this. First, we're going to try out TinkerCAD, and then we're going to move from that to Minecraft education. Actually, this lesson comes from a Minecraft education lesson. You can look it up. Build a Mars rover. Here, let's get started in TinkerCAD. So, if you've ever used TinkerCAD before, the idea behind it is that we can add together blocks. Well, not just blocks, but different geometric shapes, and subtract from those geometric shapes to make more complicated shapes. So, I can take something like a box, and a cylinder, and maybe a sphere, and make something. Well, I don't know. Maybe I'm going to hit the duplicate button. And you know what, with this, I'm going to subtract. So I'm going to take one of these, I'm going to duplicate it, make this a hole here, and then I'm going to join them together to take one away from the other. That went a little bit fast. It's okay. You can always go back, but the idea is when I hit this, that disappears. So I'm just going to do that. You see here we have a little bit of a turn arrow. Twist it. Okay. Okay. Smiley face. Oh well. I'm going to delete that. And let's try making a rover. So if you haven't seen Perseverance, it looks kind of like a car with 6 wheels. So I'm going to take a box. I'm right-clicking to turn this, change my angle that I'm looking at. I'm going to pick this up. Okay. Notice as I right-click on the grid here, I can change how I see this. I can drag over a cylinder. Create a wheel. And another wheel. And even a third wheel. I'm going to hit a wheel. I'm going to hold down shift, hit another wheel, and then another wheel after that. I'm going to right click and drag to turn it. And I'm going to hit duplicate. Oh, there we go. We're starting to look kind of like Perseverance. In fact, if I click here, I've already made one. Oh, looks a little bit more like it. I can also add on notes. So Perseverance has an X-ray spectrometer. It has an ultraviolet spectrometer. It even has a laser micro imager. Pretty cool. There's so much stuff there, and scientists tend to make stuff on a computer to make a model before they actually build something. Let's take a look at how this prints out. Okay, pretty cool, but we don't have to print it out. We could also use augmented reality. Let's see it in the Fab Lab. Here we are in the lab with our TinkerCAD created Perez-Perez model. It's just geometric shapes, but it looks pretty cool. Go ahead, try it out. All right, let's try making our model on Minecraft Education. I'm going to hit play, and then I'm going to go to Create New, but from a template. Here's our Build a Mars Rover template. I'm going to say play. In addition to downloading from the website, you can find this lesson under monthly build challenges. There's some instructions as you start, and you can also see a model of the rover. We can build our own by hitting E for inventory, choosing iron, and then right-clicking. You can also create your rover with code. Hit the C button, create a new project, tie an event to the word rover, and code it to place a series of blocks when you type in your keyword. Here we are at my rover. I used a little bit of code to make these giant wheels, and, well, most of it. The actual rover has sensors, so I put an observer block. There's also some hardware to make oxygen from carbon dioxide, which there's lots of carbon dioxide on Mars. So right here we've got our material reducer. Oh, and there's lots of cameras. We also put these solar triggers because of we have cameras, and cameras respond to light. So a couple of different functional items to represent the different parts of the real rover. How would you go about making a model of the rover in Minecraft Education? When we printed ours, it looks like this. Move forward. Oh, there we go. Let's see how it looks in augmented reality. Here we have our Mars rover that's made out of Minecraft. I really like this one. It could look more like the Mars rover, but it's got some neat functional aspects. It's kind of blocky, but why don't you go ahead and make your own Mars rover? But before that, let's talk with our friends from NASA about Perseverance and Ingenuity, the actual robots that are going to Mars right now. We are so excited to have Edmarie Sanchez Gerena here. She's an intern with NASA, and she's going to tell us all about the Perseverance rover. So I have a few questions, and thank you for all the questions you've answered already, and we've got a few more. The first one I'm going to ask is about computer models, because we've done a little bit of work on making computer models, and the kids are going to be making some computer models. Do you know, do NASA engineers, do they just start putting stuff together? Do they draw it out? What do they do when they're making models to get started?
So NASA engineers have been using computer design softwares to design all sorts of vehicles. So we can know that as cats. So scientists at NASA use supercomputers' capabilities to test those designs and analyze the data collected from those tests. And I can send you a link that I have so the kids can know about a bit more about NASA and JPL on their space robots for everyone.
Oh, great. Thank you. Let's put the link right here. Are there going to be rovers on other planets?
NASA is always coming up with new missions to explore our solar system. There are currently no plans for rover missions to other planets. However, there is a lander mission to Jupiter's moons Europa. This moon is classified as a water world and is target for the search of life. The moon is thought to have a subsurface ocean, so if a rover is planned to be part of that, take onto the moon of Europa, it will take the possible shape of a swimming rover as opposed of that type of vehicle rover that we currently see in Perseverance.
Oh, that is so cool. I have
Yes.
another question. Well, that actually answers my next question, which was how would a rover for a different planet look like? So it would it would look like something that swims. What what do you mean?
Perhaps one day we'll have some of that type of NASA competitions that they help gather to the high school students or perhaps college students, and they come up with ideas and help NASA to create something new. So yeah,
That is so cool.
that's
So
something really cool about STEM.
I agree. The kids should they should get started now. Really.
Yeah.
Drawing and modeling what a swimming rover would look like. Maybe like a fish or like a boat. I don't know. Okay, that is so cool. So Edmarie, can you explain to me some of the hardware that's on the rover?
So Perseverance has about 7 instruments, 2 microphones, and around 23 cameras. One of the instruments that is on Perseverance is called the Mars Environmental Dynamics Analyzer, which is known as MIRA. This is a type of weather station. So MIRA is supposed to help on weather measurements such as wind speed and directions, the temperature and humidity, and many other things that we perhaps wouldn't think of. Another instrument that I find really interesting as well is Sherlock. So Sherlock uses spectrometers and lasers and cameras to search for organics and minerals that have been altered by water environments and may have a sign of past microbial life.
Oh, that's exciting. So, I think I also read somewhere that there is some sound sensors on Perseverance.
Yes, so engineers have equipped Perseverance to be a great listener. It has an entry, descending, and landing. This is known as EDL, microphones that will record the sounds of landing. And another thing that it has is a SuperCams toolkit, which also consists of a microphone that will help study Mars rocks and soil. We may be able, through all these sensors, to hear the sounds of the rover itself.
Oh, wow. That's really exciting. Thank you so much for all those answers. It was great learning from you. Thank you. We also posed some questions to Natalia Perez-Perez, who's one of the engineers on the Ingenuity rotorcraft, which is a flying robot that's going to the surface of Mars right now. So we're excited to hear from her.
Hello, Steve. Thanks for having me. Hello, everyone who is listening. Hola a todos. It's an honor to be here today, and I'm very excited to talk to you about Ingenuity, the Mars helicopter.
What is Ingenuity?
Ingenuity is a small, autonomous helicopter that is currently on its way to Mars and is traveling in the Valley of Perseverance. Ingenuity's goal is to demonstrate, for the first time ever, power flight on Mars, and really power flight outside Earth for the first time ever. So it's very exciting.
What is Ingenuity's goal?
That's a great question. Helicopters on Mars can bridge the gap between rovers and orbiters by providing large-scale imagery without compromising resolution. And also, they can allow for exploration of regions that otherwise would be inaccessible by rovers.
Why are there 2 blades on top of each other, unlike mini drones we see on Earth with 4 blades at the corners?
That's a good observation. To respond to this question, let me first speak about conventional helicopters. If you recall a video or a picture of a helicopter, you can see that you have the body of the helicopter, a set of rotors in the top, and in the back you have a tail with another little set of rotors. When the helicopter spins, and when the blades spin, if the tail was not there, the body will spin too. And so the tail of the helicopter and the little rotors prevent the body from spinning. Now in this configuration, which is called a coaxial configuration, you have a rotor in the top of the other rotor, and they are spinning in opposite directions. So then the body doesn't rotate. And this configuration allows for a more compact design, which was necessary for Ingenuity, which we know it's traveling on the belly of the rover.
Why is it hard to fly on Mars?
There are many challenges of flying on Mars, especially because this is something that has never been done before. One of the challenges is that there is a delay in communications between Earth and Mars. So the helicopter needs to be able to fly completely by itself, no human input. Another challenge, which is what my team and I are working on, is the aerodynamic performance. The atmospheric density on Mars is around 1% the atmospheric density on Earth. And to fly, you need air. So Mars having so little air, per se, makes it really challenging to achieve flight. And further, there is not much research about this topic, which means that there is no comprehensive data that can help you design your helicopter. And so research has to be performed to design for the optimal aerodynamic performance that will ensure successful operations.
Please tell me a little bit about the sensors on Ingenuity.
Ingenuity has sensors that collect data to help Ingenuity understand how fast it's traveling and in which direction. For instance, one instrument that Ingenuity has is a altimeter that helps understand the altitude in which Ingenuity is flying. It also has heaters that keep electronics warm to survive the cold Martian temperatures. And finally, it has a brain to perform its functions in all operations, including flight operations.
Wow, that was fun. I really enjoyed learning more about what's going on at NASA and about robots in space. I hope you had fun learning and that you make a really cool computer model. Please let us know what you come up with and keep learning. Bye.